The domain of the vector functions are listed below using interval notation. So really it's three separate problems. It's like A, B, and C. You got to figure out what's the domain of A, what's the domain of B, and what's the domain of C. So in review, natural logarithms go from 0 to infinity if there's nothing really odd about inside there. For B, you have to set the inside part greater than or equal to 0. You're setting t plus 17 greater than or equal to 0. So t is greater than or equal to negative 17. So that's negative 17, sorry, with a bracket to infinity. And then the last one here, this one's a little bit odd, but it's you set the inside part greater than 0, not greater than or equal to 0, because you want you never want to divide by 0 there. So we add t, switch this around, t is less than 9. And then what you're doing is you're finding the union. I'm sorry, not the union, the intersection of these.
Okay.
And so you're like, well, if I start at 0 and go to infinity, that's fine. But then this says minus 17 to infinity. So where's the overlap in those? Well, it's 0 to infinity. But then where's the interlap from this one? This one's minus infinity to 9. So the overlap is of all of them is 0 to 9, it looks like.
Okay, I guess I don't understand that.
Okay, so we'll just draw a picture. So let the first one, A, this is A, 0 to infinity. B is going to be minus 17 to infinity. So right now the overlap right now the overlap appears to be this region, but then we're going to do the last one. Last one is minus infinity to 9. Actually, that's an open circle to 9. And so that's this way. And so now where's the overlap for all three? For all three, it's in here.
Okay.
From 0 to 9.
Okay.
So you just find the overlap and
Right, that makes
go.
sense.
Okay. Now the first one's probably more difficult than than I expected, but because the second one's a little bit easier because it has fewer restrictions. So let me snip letter B. We'll look at that next. Okay, so the second one here, we'll just do it this way. Square root of t minus 9. You set t minus 9 greater than or equal to 0. So t is greater than or equal to 9. Okay, so on a number line, that's 9 to infinity. Okay, all the way out. Sine of 9t has no restrictions. So it's everything. It's all real numbers.
Does sine have any restrictions?
No restrictions because it oscillates, it just goes forever. And then t squared, similarly, it has no restrictions either.
So the domain will be 9 to infinity.
That's right, 9 to infinity, because that's the, you got to be careful there. It includes 9, does not include infinity.
Right. Okay. I guess I didn't. Yeah, I didn't know that trick. If you draw it out, and they're all.
It really helps. The visual really helps, but you also got to know what all these functions do, so we can look at that. So like e to the minus 9t, there is no restrictions on its domain. So far, the only thing you're looking for is division by 0 and square roots of negative numbers.
Right.
So that's everything. That's the whole line saturated. Now the second one, you cannot divide by 0, and this one's a little bit harder to do. So you normally set t squared minus 81 greater than or equal to 0.
Right.
But because, yeah, so you just said greater than 0, but then you got to factor this t minus 9, t plus 9 greater than 0. And what you're supposed to actually do is put those two critical points on your graph, so minus 9 and 9, and then you're supposed to test each region to see what happens. Okay, so like for example, let's say, and you did this in calculus 1, let's say you test 0, 0 is in between them, you get a negative number. Negative 9 times 9 is a negative number, so that's negative. If you test, say, like 10, you get a positive and a positive, so that works out nicely, and so does negative 10. So where's the square root of this thing positive? It's positive when the, I'm sorry, the square root is positive either left of -9 or right of 9. And that's what we're looking for.
Okay.
Okay. And then the last one, t to the 1/3, it's the cube root of t. It has no restrictions. Okay, so that's everything. Now, this is your knowledge of functions is actually a really good question because you got to know all your functions.
All right.
And it's a great kind of test thing. So this one would be limited to the middle one, -infinity to -9, union 9 to infinity.
Okay. Yeah, if this kind of questions on there, I'm definitely gonna draw gonna draw these visuals.
Yes, definitely help here.
Yeah.
All right. So just another question here. This feels completely unrelated, but okay. So it says find the equation of a plane that is perpendicular to the vector 3i minus 5j minus 4k that passes through the point, this right here. So are you given a reference sheet on your exam, or do you have to remember all your formulas? Okay, so you do not. So there's a bunch of ways this is presented, but you have an x minus x naught, a y minus y naught, and a z minus z naught. And there's a couple of variations that will say equals 0. And then what goes in front is the normal vector, which
Okay.
they're actually giving it to you here.
Okay.
So it's 3. That's what goes in front. X minus, and then use your point, 2 plus -5 y plus 4 minus 4 z minus 1 equals 0.
Oh, okay.
And then how did you get this? You simplified this. Now,
Right.
I would be okay with you leaving it like this, but you gotta, it's kind of like point slope form. You just leave it. But this, you can see here, 3x minus 6 minus 5y minus 20 minus 4z plus 4 equals 0. So when you combine your constants, that's how you came
Yeah.
up with the minus 22.
Yeah, that's the part I couldn't remember how I did it.
Yeah. And sometimes the 22 is on the right hand side. I do have another question like this. It's a little bit more complicated, but this is a good starting point here. So let's all right. So next question. Actually, we'll just do part A. Find a vector parallel to the line of intersection of the planes x minus 4y minus 5z and y 3x minus 3x plus 5y minus 4 is equals 4. Parallel to the line of intersection. Okay. I wonder if this is a cross product problem.
Right.
Sure looks like it. Okay. So if we do our ijk and we do the 1 minus 4 minus 5 minus 3 5 and minus 4, so notice those constants don't matter.
Yeah.
So we get so right here the determinant of this 2 by 2, 16 plus 25 minus j hat minus 4 plus 15 plus k hat 5 minus 12, like this. So you get your 41 I hat minus 11 j hat minus 7 k hat, or like you wrote it in vector notation here. So if you get to the test, and you're not sure what to do, remember that the only way to get a new vector is through cross product.
Right.
And there's enough here. Like there's encoded in this is that vector we just wrote.
Right. So is it an accurate thing to say like if I see a problem and there's two, I guess not, they're not technically vectors, but I don't know what form they're in. What form is that called? That
So
they're
this
in
is
right now?
this is an equation of a plane, and what I don't think has been made clear to you is that an equation of the plane can either be shown with this equation or just the normal vector to the plane.
What do you mean? Like the, I
So
could,
so no, the normal vector to the plane is the 1 minus 4 minus 5.
oh, okay,
But depending on where you are on the plane, it's the one it gives you this minus 10 value
right,
or something else. So there's all these different normal vectors to the plane. So
okay,
you can either describe a plane with an equation or its normal vector.
okay. Well, like when I initially see that, I'm like, okay, that's a vector in some shape or form.
Uh, I can't guarantee that. I
Okay,
don't see this class enough to know all the variations on the problems
right,
that you're going to see
okay.
anymore. Sorry.
Oh, you're good. Just trying to see if I can find a pattern.
There's not, it's knowing the material
Yeah,
really well. Okay, part B, this is kind of this is out of left field a little bit, all of a sudden to find a vector parameterization for it.
all right,
But there's a formula, I'm sure. So the formula here is you use this point. I wish I had, this is where I wish I had, let me go find the vector parameterization equation so we can write it out formally. Okay, so the one I'm seeing is X naught, Y naught, Z naught. Well, there's a bunch of different ways, plus T, and then it's your A, B, and C of your normal vector. So this is your normal vector here, and there's other ways that you might actually see this written. But this is your X naught, Y naught, Z naught point. So it's -1, comma 1, comma 1 plus T times the normal vector, which you just found. Nine
how did I get the normal vector?
from the previous problem. Oh no,
Oh, it's part B, the same problem?
this is right though, isn't it?
Yes.
I added wrong. This should be plus 19. I just made a mistake in my
Okay.
thing. So it's like, why is that different? Yeah. It's just your other
Oh,
answer.
okay, okay.
So some books do it this way. They actually go X equals X naught plus AT, Y equals Y naught plus AT, Z equals Z naught plus AT, or sorry, these are B and C. So the X naught, Y naught, Z naught are the point. It's always the initial point
Uh-huh.
that's on both planes. And then A, B, and T or A, B, and C are the normal vector coefficients.
Okay.
All right. Okay. So just refreshing my screen with the problems you sent over. All right. Did we do that one? Yes, we did. Yeah. Okay. So here we go. This is a good question to do, kind of related. All right, find an equation for the plane through points, these 3 points here. So you can think of them as A, B, and C. And so most often you find vectors A, B, and then AC,
All right.
and then you take the cross product of them.
Okay.
Okay, so we'll do that now. So AB is the first position is -2, -3. We're using the X coordinates, 0, -3, -1, -3. And then you simplify. You can do it on the fly. I don't have an opinion
So
on that.
having two vectors, you could take the cross product of them to find the equation of the plane that they're on.
you can find the normal vector, which leads to the equation of a plane.
So
'Cause you-
cross gives you the normal vector?
It does,
Okay.
yes. Think of the normal vector as like the slope of a line. You still need the intercept.
So, um, so how would you find the equation of the plane, or are you gonna do that right now?
We're gonna do that. We gotta do this. You know, you gotta go one step at a time here. There's really no shortcut. So AC is 0 minus 3, 2 minus 3, and 1 minus 3. So that's minus 3, minus 1, minus 2. And you know, you really got to check your work, because if you make any mistakes in
Right.
this part, they just propagate through the whole problem. All right, so we got I, J, and K, minus 5, minus 3, minus 4, minus 3, minus 1, minus 2. So same thing again here. You get 6 minus 4 minus J, 10 minus 12 plus K, 5 minus 9. So that gives us 2I plus 2J minus 4K. So that is your normal vector.
Okay.
And this is again where it's 2 times X minus X naught plus 2 times Y minus Y naught
All right.
minus 4Z minus Z naught. And then you use a point, and it doesn't matter which point you use.
Right.
So it doesn't matter which point, because they all actually simplify the same thing. We'll just use that first one because they're all threes. So like, again, in terms of your like final answer, this is correct. There are different forms of a plane. There's like standard form. I don't know. I don't even remember what this one's called. Is that okay?
Yep.
Okay. All right. So next question. We did that one. So I know you can't see, but I'm trying to do this. Okay. So we got all right, find the point at which this line intersects the plane. Okay. How do we do that? Sorry, I'm just a little, I actually don't know. So let me go look up a reference for this, and we'll get back to this problem.
I'll be right back.
Okay.
All right, I'm back.
Okay, so it's actually more straightforward than I thought. So I mentioned we sort of wrote this form earlier. So
Right.
the form is x equals and then x naught plus at. But in terms of this problem, it's -5. It's that first value. That's your x naught plus -2 times t. Okay.
Okay.
And so where am I going with that? Well, we're going to do the same thing for the others. 5 plus 3t, and then z is -5 plus 2t. Now in this equation over here to the right, it's got x, y, and z. So we're gonna substitute in our parametric form
Okay.
for this. And the nice thing is, I'm gonna run out of space here, that we're gonna only have one variable when we're done. So each of these three go in for x, y, and z. So
Okay.
that's 5 plus 2t plus 25 plus 15t minus 10 plus 4t equals 83. We pray this works out to 15, was that 21t, 15, 520 plus 20. Yes, this is plus 20 equals 63. And you solve and t equals 3.
And
I'm
you
sorry,
plug it all back
83.
in.
Yeah. So then you plug that back into
Okay.
this right here. Good question. It's a parametric form
Right.
is useful for a lot of things. You will see it again in this course.
Wait.
Yeah. Okay.
That makes sense.
Why?
I think that might have been all the questions I.
Yeah, there's one more here.
Okay.
I think. Apologize for that background noise if you can hear it.
I can't hear it.
Literally. Sounds like they're cutting down a tree next door. Okay. All right. This one is really similar. Okay. They give you the parametric form already, so you don't have to come up with it. So you just put those in for each of the variables, and then you solve for t. So we get 1 plus t plus 2t minus a minus 3t equals 4. And so 3t, 5t, 6t, 6t plus 1 equals 4. So t ends up equaling 1/2. And then you put that back in for each like that. And now that you've seen it, it's, oh, I can do that. No big deal.
Yeah, it's like I said, like
We've got one more here. Can do at least. I understand it's a lot. It's really a lot, but there's a reason you got through Calc 1 and Calc 2. Like you're more than capable of doing this. It's just, time and effort. Okay, find the parametric equation for the line through this point that is perpendicular to the plane 2, 0, minus 4t. So again, the parametric form x equals x naught plus at, y equals y naught plus bt, z equals z naught plus ct. A, B, and C are from your normal vector. Your normal vector is 2, 0, minus 4. This is your x naught, y naught, z naught. So a lot of words that, basically ask you to just write it in this form. So x equals -4 plus the 2t, y equals the 2 plus 0t. That's why it goes to just 2. Z equals 3 minus 4t. Part B. So part B, they ask you about when t equals 0. So you just put 0 into each of these. So x equals -4 plus 2 times 0, which is -4, y equals 2, and then z equals 3 minus 4 times 0, which is 3. That's your ordered pair for that. We got a parameterization. So there it is kind of heavy with parameterization in this. You're currently muted if you don't know.
Oh,
It's fine,
sorry.
just fine with me.
I thought I unmuted myself.
Yeah, I don't know if you've done this before. Have you tried clicking on solution to see how it is, if it's good for you or not?
I actually haven't.
Okay, sometimes that will really help.
Okay.
Depending on the problem. Like some give you really nice ones, some don't. Okay, so x equals cosine t, but there's usually an r here. Y equals r cosine t. You saw this in pre-calc trig. Okay, and they're telling you, I'm sorry. No, sorry, this is completely wrong. Apologize. Y is 3, and z, we're going to use really z for sine, so it's r sine t.
Okay.
Like normally y is sine, but because it tells you that y is 3, you use that one first. Okay, so if they said x was 3, maybe you make y sine and z cosine. It doesn't really matter, but you're going to do this a lot. You're going to do parameterizing a lot with sine and cosine in this course.
Okay.
Okay, so then you just plug these into your equation. R cosine t squared plus 3 squared plus r sine t squared equals 34. So this is 9. That's what's nice here. You get r squared cosine squared t plus 9 plus r squared sine squared t equals 34. Next part is to subtract 9 from both sides. So you get 25 on the right. And then out of these two, you can factor out this r squared. And you're supposed to remember from pre-calc trig that sine squared plus sine squared is 1. So r squared equals 25. So r equals plus or minus 5 in this problem. I bet there's 2 solutions. Do you have this one up? Do you mind looking at it just to see what it looks like? They usually only post these after a certain while, and sometimes some students will print them as PDFs and keep a log of all of
them. Which does it say which problem it is?
Vector functions problem 11.
Okay. All right. Okay. Do you want me to send you the solution?
No, it's up to you. I just was wondering, you could just look at it and see if it's helpful or not. It may.
Okay, so what it did is
it doesn't give it.
Substituted y for 3, so it's x squared plus 3 squared plus z squared equals 34, and then it ends up being x squared plus z squared equals 25.
Yes.
And it does x equals square root 25 cosine t. Z is square root 25 sine t.
Yeah, so not super helpful. It doesn't really give you the full scope of it. It just gives you a how-to if you had similar problem. But all right, it would appear that we've gone through everything. Please tell me if you think there's something we missed.
No, we did all the problems.
Okay.
I get the rest of the problems on this.
All right, I've got something else I can pull up.
Yeah, that'll work. It's probably
where did So just a small bit of self-promotion here. I put up a question of the day, and this one's for physics, but it's really for your class. I don't have enough vector calculus students, but if you want to follow me on Instagram, I do post stuff like this. So it's like, which of the following actually like exist, or in the case here, like you have to decide scalar, vector, and so on. So let's look at A dot B dot C. Okay.
Uh-huh.
What is A dot B? What does that produce? Do you remember from yesterday?
Sure.
Yeah, it's a number. So I had scalar, right? So is a scalar times a vector, in this case C, what does that produce? It's a vector.
Yeah.
So that's false. Okay. There's no way to make this true, by the way. It's just
Okay.
impossible. I mean, you'd have to add a D or something to it. Now the next one says A dot B cross C. So again, A dot B is a scalar. You cannot cross a scalar with a vector. This is impossible.
I'm muting myself. My dogs are barking. I'm
That's
hearing
okay. Okay. Just want to make sure that's clear because like you, it kind of looks like it could work, but it doesn't. Okay, so now A cross, this is part C. Let me go A, B. So A cross B cross C. So let's, small technical glitch here. Okay, so when you cross two vectors, you get another vector. We'll call it D. Okay, so then when you cross that with C, you get yet another vector. We'll call that E. So cross product always produces a vector, even if you have a bunch of them in there. So that, again, these are all false so far. Okay. I'm going to pull up one for you to do if you want, but I've got another one like this. So D is A cross B dotted with A cross C. So we just said that the cross product produces a vector. The dot product of two vectors is a scalar. Okay. E, we've got the dot product of two vectors crossed with the dot product of two vectors. So when you dot two vectors, that's a scalar. Scalar cross a scalar is impossible. So this is also false. Now it might be leading you to think, well, what is true? But a lot of times these questions are written such that they're trying to get you to remember like what you can't do, not what you can do.
Right.
When you're doing this. You can dot two vectors and get a number. You can cross two vectors and get a vector. So like what can you do? Well, you can always do A dot B, A cross B. That's always true. Okay. But if you start out with A cross B, you get another vector. So you can cross it with C. That's okay. You can also dot it with C. That's okay. Because a vector dotted with a vector is fine. A vector cross a vector is fine.
Right.
And these are really it. I mean, there's not a lot of other things you can do.
Uh-huh.
So let me pull up this other thing. It was a practice test. Let me see if I can find it. Oh, yeah. Okay, let's look at this one. It's not product. It's not vectors. It's not all vectors, but it's, so we'll skip some of the ones that are irrelevant to you.
Okay.
So you said you have not talked about cross sections or level surfaces. Is that right?
I don't think so.
Okay, so we won't do those. So let's look at C. A normal vector to the plane 2y equals 1 minus x is minus 1 minus 2j plus k. All right. So one of the problems with this is it's not even written in the right format here. So you really don't want to have like x's and y's all on one side. So let's move the y right. So it's minus x minus 2y plus 1 equals 0. Okay. So what is the normal vector to this? It is minus 1 minus 2, 0. There is no z here, no z. But see how it's really close to that?
Yeah.
It makes you think, oh, it must be.
Yeah.
Okay. All right, so that's obviously false. Okay. Have you talked much about three-dimensional spaces, shapes like a sphere?
Yes.
Okay, so a sphere, x squared plus y squared plus z squared equals 15. Its radius is the square root of 15.
Right.
Okay, and so that means it only goes out square root of 15. It doesn't go out 15. Okay, so your sphere, which is really hard to draw in 3 space, but centered there, you go up, you know, it's got kind of this shape like that. Where is x equals 15? Well, this is the square root of 15 right here, which is a lot smaller than 15. So this plane 15 is like over here, but they don't intersect.
Right.
You know, I think, you know, it'd be like holding a basketball in your hand and your friend's got a sheet of paper over here to the right or left, and they just don't hit. So again, that's also false.
Okay.
Okay, now this last one here, a dot x plus y is a scalar. So problem is we don't actually know what x plus y, we don't know what they are,
Right.
but they're not vectors because there's no vector notation here. Like
Right.
it's kind of like degree and radian. If it's got the degree symbol, it's a degree. There is no way to know what this is, this x plus y. Okay, other than we can say it's not a vector because there's no vector notation here.
Yeah.
Okay, now this is how you can make it true, which I know it's nice, but let's say it was a dot x I hat plus y j hat is a scalar. Okay, well, you can always dot 2 vectors, and we don't know what a is, but whatever the component x component of x is, it's going to dot with this x component of x of this vector. Similarly with y and z, you get a number, even though the number might contain variables in it. All right, so let's find some other stuff here. Downloads. A couple more of these types of questions. I think we actually looked at a couple of these already, but okay. Right, true or false? It is false justified. All right, so a dot b dot c is a scalar. Kind of already looked at that. If you dot 2 vectors, you get a scalar, but once you add a third in, you're taking a number times a vector. That gives you another vector. So this one would be false. It actually produces a vector. I think we actually did B earlier. A dot B is a scalar. You can't cross a scalar and a
Oh yeah.
and a vector. So that's also false. Now you'll notice that this one has parentheses, but this one doesn't. So the order does matter. They have to tell you here to dot before you cross, because if they went A dot B cross C, okay, if you cross, you get another vector, right?
And you could dot 2
And then
vectors.
you could dot. That's why they're there. In the problems I was showing you earlier on this thing right here, I did that where necessary. But like in part C, it doesn't matter whether you cross B and C and then A with it, or do A and B and then C, same result. But but parentheses do matter. So
Yeah.
you know, pay attention to that when you're doing this. Okay, what do you think about C? What's your intuition tell you about C? A vector A divided by vector A. Have you ever divided 2 vectors?
I no.
No, and you actually never divide vectors.
Right.
So here's what is true. The magnitude of A
Yeah.
divided by the magnitude of A
Yeah.
is 1. But this is also false.
Yeah.
For the same reason. All right, so last one here, A cross B, that produces another vector D, we'll say, and then D dot C, yes, that is a scalar, so that is true. And I don't know why, they just tend to be more falses than trues in some of these that I'm looking at. Now yours, you know, it could be different. It could be different. All right, so I've got one of these equation of a plane problems that we can do next. No. So you didn't do any, I know I've asked like multiple times, you've not done any contour diagrams.
Not for this test, no. I think we're
Okay.
starting to get into it, or we talked about it, but it's not on this test.
All right, so that won't particularly help. Okay, let me do another snip.
Is that like having to do with like topographic maps or whatever they're called?
Yes, yes.
Yeah, those won't be on this test.
Okay. All right, find the acute angle between the two planes, x plus y minus z and 3x plus z. Give your answer in degrees. I know you said you won't have a calculator, but you can still write it out. You don't have to actually calculate it. So the cosine of theta, the angle between, is the magnitude of the two vectors. I'm sorry, it's the dot product of the two vectors. Magnitude of u, magnitude of v. Okay, or like we learned yesterday, the tangent of the theta is the dot product. No, I think it's the magnitude of the cross product
Oh,
over u dot v. I think we might want to check that out. So you actually have a choice.
yeah.
I mean, I tend to remember this one. So we'll go with that one. So the dot product is 1 times 3 plus 1 times, well, there's nothing there, 0 minus 1 times 1. Okay, and then the magnitude of each. So we've got 1 squared plus 1 squared plus minus 1 squared square rooted. So that's the square root of 3. And on the other one, we've got 3 squared plus 1 squared, so square root of 10. So it looks like it's 2 over square root of 3 times the square root of 10. And that's why you need a calculator, because who knows what this is. But your class, you might get one that works nicely.
Okay.
I don't know.
Hope so.
Yeah. I don't know. What other questions you got here? Running out of stuff to send you.
Yeah, we can be done if
Okay. All right.
now
Well,
it just comes down to me practicing.
yeah, you can do this. And truthfully, this should be the easiest test of the semester. So this is the
Yeah.
one to really nail, because you'll want to make up for it later on.
Right.
Class gets like exponentially more difficult.
Yeah.
All right, Trenton.
Trenton.
Thank you so much for
Right.
scheduling. Glad to help as always, and
Yeah.
send you the notes here shortly.
All right, appreciate you.
Okay, have a good day. Bye now.